Hi everyone and welcome back to the AI Concepts with Coding from Scratch series. In this video, you will learn about the k-means clustering algorithm as well as how can you implement this k-means clustering algorithm from scratch using Python. If you want to learn Python, data science, machine learning and Gen AI, subscribe my YouTube channel. K-means clustering is a unsupervised learning technique that is used to solve the clustering problem in machine learning or data science. It's also called the centroid-based learning algorithm. That means it will calculate the centroid of the data point. Let's take one example and try to solving this algorithm by following some steps. Those are steps that you need to follow. First step is decide the number of cluster, that how many cluster you need to assign. Then you have the initialize the centroid, because we know that k-means clustering is nothing but an centroid-based algorithm. Centroid is nothing but the middle of the data point. Then you have the assign the cluster, you need to assign the cluster to our data point. Then you have the move the centroid, because you need to move the center so that you can go to the exact data point, exact center of the data point. Then you have the finish. So this is nothing but the backbone of this whole algorithm. Assign the cluster and then move the centroid. Okay, just need to centroid, move the centroid each and every time. So I will take an examples from dataset that's called diabetes dataset. We have the blood pressures and the ages. So simply going to plotting this out in a 2D plot. So let's say we have the 5D data or 5D dimension of the data. So how can you plot them? Because this is a 2D data, we can simply go to using the Scikit-Learn to plotting this out. So if I have the 5D or 10D or 4D plot, we cannot plot it, or even we cannot initialize the number of clusters. You can see that it maybe have the number of clusters should be the 3. Okay, but in the real-time examples, your cluster is not exceeded to the 20. Okay, so I'm just simply going to taking one cluster as a 3. I just going to taking as the k equal to 3. So why k? Because this n is nothing but denoted as a k, because this algorithm also called the k means clusters. So in this case, I'm taking the examples of number of clusters nothing but the 3. Okay, so you can also using here some kind of method to actually decided that how many cluster you can choose in order to solving your problems. So you're having some data point, let's say this data point, this data point, and those data points. Now our first step is decide the number of clusters. So decide the number of clusters is nothing but 3. We decide that randomly, okay, for these problems. Then you need to initialize the centroid. So how can you initialize the centroid? We can initialize the centroid in a randomized. You can randomly flip the coin. You can it may be head or it may be tail. So same in this case, you can calculate. You can initialize the centroid in a random base. So I'm taking two centroid. Let's say dot or cross. Let's say right sign. So then we need to calculate the equivalent distance of each of the data points so that you can also make them in a cluster. So let's assume that this is nothing but one yellow. This is the right dot. Then we can taking, let's say, the red. Let's say this is the red. This is the red. Let's say this is the green. We can say that, let's say this is the green. This one is the green. Okay. So you can calculate the equivalent distance. We know that the formula of the equivalent distance to calculate each of the data point, it's nothing but x2 minus x1 whole square plus y2 minus y1 whole square root over. Okay, this is how we can calculate the equivalent distance of the two data point. Okay, but what about the 5D or 10D? But the formula should be vary on that. So you can see that if I calculate the centroid, if I calculate the distance from the data point of the red, so those are the nearest point of this red. So you can simply go into making this all of them as a red. So let's say red, 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 and red. That you can see assign the cluster. That's been our first step is done. Second step is also done because we initialize the centroid. The third step is going on, assign the cluster. So assigning this cluster as a red cluster, then we can simply go into making this one as a green, because this is nearby this green. And let's assume that this is nothing but near to the yellow. So you can making this one as a yellow as well. Yellow. Okay. This one yellow. Let's say this one also yellow. And this one is nothing but the red. Okay. That's our step number 3. It's called assign the cluster. We assign the clusters. Now this is our cluster. So this is our cluster for the red that you can see on here. Okay. This is a cluster for the yellow that you can see yellow. Cluster for the yellow. Okay. Cluster for the yellow. And this is a cluster for the green. This is the cluster for the green. Cluster for the green. Okay. So now we need to move the centroid. You can see it's nothing but in a loop. okay, until we found the centroid to keep doing this task. Okay, so let's go to the next slide. And you can see here we actually calculate the centroid. This slide and this slide is almost same. You can see because we consider this one as a dot point, so you can see dot points go to in these sections, and this point is this right sign is going to this point, and this one is going to this point. That's mean to calculate the centroid, assign the clusters of each of the data point. Now this is one cluster, this is one cluster, this is one cluster. So we can simply going to assign in this one. Let's say this is the green. Let's say this is the green. Okay. Let's say this is the green, and let's say this is nothing but the, let's say this is the red. Okay. Red. Let's say this is the yellow. Okay. Just for assumption. Okay. So you can see here now we have the we actually calculate the cluster of that. Now we have to calculate the center of each of the data point. So in previous, what you could do, we're simply going to choose the randomly actually initialize the centroid. Now we need to in order to calculate the centroid, we need to using here the mean of the these two data, because we have the BP and the H. We're taking the mean of that, and you can calculate the centroid for that. So you can see that now we need to move the centroid. How can you calculate? See, because we already decide the number of clusters, we also initialize the centroid in a random way. Then we also assign the clusters. Now to move the centroid. Okay, so this thing center should be coming on here. For this cluster, the center should be coming on here, or this cluster maybe center is coming on here. Okay, I just assume that. So we can calculate the centroid using the mean of these two features column. Okay, because we're plotting in the 2D plot. So after that, you can see here our centroid is coming on here. Coming on here, coming on these sections. Now the question is, when is stopped? See, this is an empty infinite loop. We see that, but when we should stop? When this new centroid is equal to the old centroid, that we can stop, because we don't need to calculate the centroid anymore. We can getting here the exact point of the data. Okay, we can actually calculate each of the group and try to calculate the cluster of that. That's mean our condition is nothing but if the old centroid is equal to new centroid, we can stop. But in here you can see that this is the center of this data point, this is the center of this data point. But if we actually making this whole of the data point in these sections in this way, so our center should be moved in these directions, in directions. But you can see here now this cross sign, this cross dot is if I calculate distance for that, you can see this cross dot is nothing but near to this dot, and also this tick mark. Okay, so this is nothing but it's going to the one single cluster, because you can see that, because this data point you can see on here, if I removing this one, you can see again. So you can see here we have the centered of the each of the data point for this tick mark, this dot, and this cross. But if we simply going to calculate the centered, how can you do that? We can do the mean and the age, as well as we can actually calculate the distance, Euclidean distance. Now in this section you can see here, if we calculate the centroid for this one, those are nothing but the nearest one. Those are the nearest one. That's mean this cluster is assigned into this cross. So see, this cluster is assigned to the cross, and that's our center right now. But yet it's not a center of the data point. Our center should be going inside this middle, inside this middle, inside this middle. Same in the next slide, you can see here it's going to the middles. It's going to the middles. See, this task is until actually replacing the whole centroid again and again, until it will finding the new centroid to the old centroid, and then we go to the finish. See, in this cluster you can see here we cannot do the calculation anymore, because you already calculate centered for that. You can centered for that, centered for that, and centered for that. But in here you can see here it not calculated here, because it is near to this point, this point, and this point, and this point. Now in this here you can see that, in this you can see that those data point is near to the centroid, those data point is near to the centroid, those data point is near to the centroid. That's mean our k-means clustering algorithm is working perfectly, and we can go to this finish step. Now the problem is, how can we calculate the number of clusters using this algo method? Because see that we actually initialize the k is equal to 3, because of we know that how many clusters we have. But let's say we have the 5D or 10D data. How can you calculate the cluster for that? Yes, we can calculate the cluster for that using a formula called elbow method. So elbow method is nothing but one curve. So in curve, you have the x-axis and the y-axis. And the x-axis, we have the number of clusters, how many clusters we have. Then you have the WCSS, also called the within cluster squared sum. Within cluster squared sum, also called the inertia. So we actually calculate some of the curve, and this point, this elbow point, is nothing but our number of clusters. So that's our data point. Let's say this is our data point. Now, how can you calculate this WCS? We know that the full meaning of the WCS is called the within cluster in cluster square sum. So let's say we have the 4 data point. So we need to calculate the centroid for that, because if we see that, you can see that we already get in the centroid for the each clusters. So we can calculate the distance for that, and then after distancing, we can simply go into using the squared, and we do the summations. Okay, this is called the WCSS, within cluster squared sum. So this, using this formula, we can calculate the WCSS. So when you get the WCSS, you can simply go into using here on dot, or you can simply go into plotting this out. So let's say we having the another WCSS for the another cluster. Let's say I'm going to calculate these clusters. These clusters I got in this formula. So I need to calculate this WCSS, this WCSS on here. So we having the another WCSS. Let's say we need to calculate this one for this one. So we have the another WCSS. So after combining them, we can getting here one added WCSS. That's we need to adding all of that. So for getting here all of the WCSS value. That's mean if we have the number of clusters, let's say for this one you have the one clusters. So for this, we actually plotting here this WCSS that you can see on here for the one. So let's say you have the two clusters, so you divide them into two clusters. Let's say two these clusters and these clusters. So you're having this one, and for these three clusters, let's say three clusters, we're having this one. That's mean how the number of clusters increases, our WCSS values decreases. You can see on here like that. Okay. So you can see here for the cluster number WCSS, we're simply going to adding all of them. Okay. So if we adding all of them, we having one curve like that, elbow graph. Okay. So let's say we actually see one thing inside this algorithm, that is, if we have the number of clusters nothing but the one, this is called the WCSS one. If the number is nothing but the two, it's called the WCSS two. And if the number is nothing but the three, it's called WCSS three. That's mean for the one clusters, we have the higher value of the WCSS. You can see here. That's mean in the first WCSS we have the higher value. Okay. If the lower one, if it is less, if it is increasing again, okay, we have the less number of WCSS value. That's mean in the number one we have the maximum number of the WCSS. So same thing, let's say we having 100 data point. So maximum number of the cluster should be 100, because we can assume that one of the data point as a one single clusters. That's mean our distance is nothing but 0, because this data point to this data point is nothing but 0. That's mean if I have the number of cluster is the 100 for the 100 data point, our cluster or the WCS value is nothing but the 0. Okay, because sorry, not 0 actually. WCS should be the 100, but the Euclidean distance is nothing but the 0. Okay, that's mean you cannot using here the 100 as a your WCS value or the number of clusters. Now, how can you calculate the elbow, and how can we calculate the K value from here? We can, if I draw this one, so if I draw this one, you can see if I draw this one, so you can see here in these sections, how in the slope is reduces in these sections, we can taking it as the elbow point. That's mean in here the slope is decreases again like that. So this is the point where you can stand. Okay. After the slope is reduces. So this is how you can calculate the K value from here, and you can use it to cluster Euler algorithm. But in real world examples, 20 is the maximum number of the clusters. Okay, because you cannot cluster your customer in a 20 classes. Okay, you maybe cluster your customer in the 3 classes. And using this cam in clustering, you can also do the image segmentations in your objects. Okay, so now we simply go into building this cam in clustering algorithms from scratch using Python programming language. Let's go on here and try to implement these ones. So right now we are going to creating here our k-means clustering algorithm from scratch using Python. So first I'm going to importing here NumPy. Let's say import NumPy s and p. After that I'm going to creating here a class called k-means. So let's say class k-means. This is our algorithm. Then I'm going to initialize here our constructor. Let's say init, and then I'm going to passing here the self and using here number of cluster, how many cluster we have. So let's see cluster clusters. Let's say by default I'm going to passing here the 2 clusters. You can pass it here as a nan as well. Then I'm going to give you here the max number of iteration, how many iteration we can choose. Let's say 100 in order to getting here our centroid point, because k-means algorithm is nothing but one centroid based learning algorithms. So that's why I need to give you here these max iterations. And then I need to do the initializations of the number of clusters as well as the max iterations. So let's say self dot number of clusters is equal to number of clusters, and then self dot max iterations is nothing but our max iterations. And then we're to creating here two another variables here. One is for the centroid. That's a centroid self dot centroid. Centroids, let's make it as a nan because we don't have any centroid yet. And then we're also creating here a variable for inertia. Inertia is nothing but our elbow method. It's also called inertia. Let's say inertia. And our inertia is nothing but, let's say, none. Okay, fine. Now let's defining here a function. Let's call fit predict, because this is one clustering problem. We have to fit it in the same way as well as the predictions, because we want to cluster them in some kind of data points. So let's say def fit and let's go predict. And then we're going to pass in here self and the x. So here x is nothing but our features column. I mean our features of our data. Then we're simply going to go on the slide and try to check that which kind of step they need to follow. So the first step is decide the number of clusters. Okay, so we're going to passing it already in here as a by default is a 2. You can pass it in your parameters as arguments, but we do here a first step. The second step is initialize the centroid. So how we actually initialize the centroid? We initialize the centroid in a randomize. If I see on here, we simply going to randomly choosing here 3 data point, because our number of cluster is nothing but k equal to 3 in this case. So in our case, we have the 2. Just to pass it by default. You can pass it 4, 10, whatever. It's up to you. Okay. So based on that, I'm simply going to creating here one random data point. So let's say I'm going to using here random. So it also import it. Let's say importing here the random, and then I'm going to using here random.sample, because this is sampling data, randomly sampling here for the centroid. Then I can use here the range function. I'm going to take it range from the 0 to x dot shape. So x dot shape of 0. So why 0? Because we're going to accessing here all of the row for here. So that's why shape of 0. And then we have we're to passing here our self dot number of cluster. Let's say self dot number of cluster, because based on the number of clusters we are going to do the sampling. I mean how many data point you're going to choose. So you're going to passing here number of clusters is 2. Let's pass it here 3 as like our presentation slide. So we pass it here the 3. So it will taking here the 3 clusters and try to choosing here 3 data point in our data, just like that. And then let's assign into a variable called random index. And then we're going to calculate the centroid. I mean make it as a centroid. Okay, you can see on here we make it as a centroid. You can see on here. So let's try to do it. Let's say self dot centroid, because we already created the variable centroids, and we are going to making, okay, we're going to making this one. It should be centroid, should be like that. The spelling is not correct. Let's say IODS centroids. Okay, like that. CENTROIDS, like that. Okay, self.centroid. That's so bad actually. Self.centroid equal to x of random index. Okay, random index. I mean the random index that you got, you're going to passing it inside the x, so that you can get here our centroid, initial server centroid. Now this second part step is done as well. This initial centroid. Now third part is called assign the clusters. So I'm going to assign the clusters. So for that, we're going to creating here a functions that's called the assign the cluster. But before that, we need to also using here one for loop. If I see that this is one loop itself, you can see loop itself. Okay, loop is nothing but about number of iterations. I mean how many iterations we're going to use here for assigning the clusters as well as the move the centroid. So let's go on here and try to check that using here, let's say for I in range, and you can use it here self dot max iterations. Okay, you can using here the dash sign in order to removing some of the memory spaces, because we are going to creating here a variable called I. Obviously to taking time, just make it as a blank space because you are not going to use it here. So let's try to use it here. Let's try to creating here a cluster, assigning the cluster. So we're going to creating here function. Let's say self dot assign cluster. Let's say assign cluster. Okay, let's assign clusters. Let's try to assign underscore clusters, and I'm going to pass in here the x itself because we need to assign the clusters. So how you actually assign the cluster? You can assign the cluster based on the Euclidean distance, right? Euclidean distance. So we're going to creating here functions called assign the clusters. So let's go on here and let's say def assign clusters, and I'm going to pass in here self and the x. Okay. So first, what I can do is simply going to taking all of the features column iteratively and try to creating here our distance from each of the data points. Now, how can we calculate the data point from here? Because it may be 2D data, it may be the 3D data, it may be the 4D data. So what are the equation for that? We see that if you calculate the data point from the one point to another point, you're actually using the same formula, just like x2 minus x1 whole square plus y2 minus y1 whole square root over. But what about the 10D, ND data? What about the ND data? So the equation is nothing but, I collected it for the geeks for geek. Let's go on here, try to read about this Euclidean distance formula. Okay, I just got this block. Euclidean distance is defined as the distance between 2 points in the Euclidean space, because it's nothing but a scatter plot. And if I go down, you can see that this is the formula for that I already discussed about that. X2 minus x1 whole square plus y2 minus y1 whole square root over. And for the 3D data, it should be x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. For the 3D space. Now, what about the ND? The equation is look like that. D equal to root over summation of x2i minus x1i whole square and root over. Okay, you can say root over summation of x2i minus x1i whole square. That means a minus b whole square like that, and the summation of that. So now we can creating here this formula. Okay, so let's go on here and try creating this out. Okay, so now I am simply going to iterate to all the value from here, because x have many kind of features. So let's say x for row in x, because it's nothing but the row. Now we're going to calculate the distance for that. That's called the Euclidean distance. So let's say distance is equal to, we're going to using here this list comprehension. Let's say np.squared, squared, and you're going to using here np.sum, because you have to do the summation of that, of the row and the centroid, because we have the row as well as centroid. Because when you assign the cluster, you need to calculate the distance from this centroid to this data point. Row means is nothing but the data, and centroid is nothing but this centroid from the centroid. So then after that, what we do actually, we actually calculate the cluster of that. If I go on here again, we assign the clusters. See, we assign them into one single cluster. Okay, so let's go on the code again. And then we have to assign the centroid. Now, why are actually centroid coming up? Because centroid may be vary. If we give it a 3 cluster, our centroid having 3. So we can using here in for loop, to iterate to all the value from here. So we can using here, let's say for, we can, let's say use it here. Let's say for centroid. Okay, should be centroid. Okay, let's say self dot centroid, and let's say in for centroid, let's centroid centroid in self dot centroid, and we can pass it to here this centroid. So this centroid, and we're going to using here a squared, okay, and whole square. Okay, so you can using here this, let's into 2 like that. We can use it here. Okay, so you have the formula np dot squared of np dot sum, summation of a minus b, let's say a minus b whole square. Okay, and you're getting the centroid from here, because we have the 3 cluster. For the 3 cluster, we have the 3 centroid. Now we calculate the distance of each of the data point towards centroid. Now we can simply go to assign it into a list. Let's say cluster group. It should be cluster group. Let's say this one, and we can pass it to here. Let's say here you go dot append but we're to taking here the minimum distance from here, because if I see on that, we're taking the minimum distance. If I go on here, you can see here the minimum distance of the centroid is nothing but this data point. That's why I assign this data point, and this right sign of this one is nothing but this one. Okay, so that's why we have to calculate the minimum distance from here. So we can calculate the minimum distance using this np dot argmin, and we can passing here the distance. Okay, that's our cluster group. Now we can return it. Let's say return here this np dot array, and you can pass it here cluster group. Let's say cluster group. That's it. We assign the clusters. Now our next part is nothing but the move the centroid. So let's try to go on here our okay, let's try to cut this out and try to take some shell and try to implement in here our next one. Let's call the move centroid. So better we can assign it to a variable. Let's say cluster group. Let's say cluster group is nothing but n list, and then we need to calculate the centroid. But before that, we need to also store the old centroid. That's old centroid. Why? Just because of we need to also stop, right? It's a centroids dot copy. Why? Because we need to giving here conditions high and the old centroid is equal to the new centroid. That's mean we don't need to using the max iteration anymore. We got in here our clusters. That's our nothing but our stopping method. Because if I see on here, in here you can see here this is a loop. So it also break this loop in order to giving here some kind of conditions. So how to break them? If the move centroid, I mean old centroid is equal to new centroid, we can simply go into stop them. Now we can using here self.centroid, and we can using here a method. I mean we're creating here a method. Let's say move centroids. Okay, centroids. अरे बनान ठीक है ना भाई? बार बार गलत हो जाता है. Centroids, and you're going to passing here x and the cluster group, So why this cluster group is passing on here? If I see on here, when you move the centroid, we simply going to move the centroid based on the clusters. If I see on here, here you can see here based on our cluster groups. That's why, because you already clustered in a group, we need to move the centroid, and in here the centroid is coming on here. So that's why you need to pass here our cluster group. Now let's try to creating here functions called move centroid. Let's say def move centroid. We're going to passing here the self and x comma cluster group. That's our cluster group. Now let's try to creating here this one. Let's call the move centroid. And now let's go on here and try to taking all of the value. Let's say for I in range of the self dot max iterations. Now number of clusters. Because based on the cluster, we're going to creating here, we're going to move the centroid. If I go on the slide again, you can see here based on the cluster, how many clusters you have is simply going to move the centroid. We have the 3 cluster on here, so we need to move the centroid based on these 3 clusters. So further it's creating here for loops, and then we're going to calculate the points. So how can I calculate the points? So you have the x, and then you're going to using a cluster group. Let's say cluster group. If the cluster group is equal to I mean this cluster is our point. This is our point. See how? Let's say we have the 3 clusters. So let's say we have a cluster called, let's say I'm going to go on the next slide. This one. Let's say this is on green. Let's say this cluster is assigning into the green cluster. Let's say this is the green cluster, and this one is nothing but the yellow cluster. Let's say this is an yellow cluster. Then you have the red cluster. Let's say red cluster. This is the red cluster. Let us see, we have the 3 cluster, right? So based on the cluster, we are going to calculate the point, because this which point is related to which clusters. That's mean we have 3 cluster. Let's say this is cluster number 1, this is the cluster number 2, this is cluster number 3. So this cluster number 1 data point is nothing but this one. Cluster number 2 data point is nothing but this one. Cluster number 3 data point is nothing but this one. Yeah. So you can go on here and try to calculate the point for that. If the cluster group is equal to I, because in our cluster group we have all our point. Okay, if it is matching this one, we're simply going to taking all of that data from here. That's our points. Now from this point, we're going to checking that if the length of the points is greater than 0. If it is greater than 0, that means we got here some new data point. We got here the new centroid. If you go on here again, then you can see here, in here we can getting some of the point, because this centroid is closing to this data point, this data point, this data point. That means the length of the point is obviously greater than 0, because you can see here we can go and calculate the new centroid. If I go on here, you can see here now all of the centroids calculated. That means length is 0 for the point, because we already calculated the points, and you have the 3 clustered as well. Point is same. Okay, if it's greater than 0, that's mean we have to calculate the new centroid. So let's go on here and try to check them here. Okay, let's say new centroid. We're creating here a list. Let's say new underscore centroids. Let's say troids centroids is equal to list. Okay, I'll cross check later on, because एक बार मैंने बहुत हो सकता है गलत कर सकते हो, क्योंकि जो बनान है ना सेंट्रोइड, वो मुझे बहुत अजीब सा लगता है. Okay, let's say new centroid, and I go to append it. Let's append it based on the, let's say, points dot mean value in the axis of columns. Say why. Let's go on here and try to check this out. Okay, not here actually. So I have one text, I already put that. You can see here. Now you have to calculate the move centroid. How can you calculate? We can calculate the centroid to take the mean value of the BP and H. Mean value, you can see BP and H is nothing but columns. So taking one of each of the columns, I try to taking the mean. So in the column wise, axis is nothing but equal to 0. Okay. And you have the centroid. Then you have the else of the new centroid dot append, and पुराना centroid यहाँ पर दे दो बस. Let's say centroid, self dot centroids. Centroids. Okay. So of the I. Okay. Then we're going to returning here. Let's say return here the np dot array, and we're going to passing here our new centroid. Okay, that's it. Because we need to keep the centroid if no point is already assigned. Okay. So we have the centroid right now. Now we can simply go into checking that. I'm going to checking that. Let's say if the np dot all close of the self dot okay, let's do all centroid is equal to self dot centroids, then we can break them. Okay, if it is equal to this old centroid to the new centroid, because in here new centroid is copied, you can see on here, so you can break them if it is not changes. Now we need to calculate the inertia, because you need to also check the elbow method to getting that how many cluster we can choose. So let's say self dot inertia. So let's say inertia is equal to sum of. So how can you calculate the inertia? If I go on here in the elbow method, you can see you calculate the inertia in a WCS method, within cluster squared sum. Within cluster squared sum. Let's try to do that. So let's say first sum, we have the np dot sum, and we can using here, let's x of cluster group, so is equal to I is nothing but the number of features. So where we can got in here, let's say for I in range, and we can give it here our self dot cluster, number of clusters. Now you can simply go into minus it. Let's say minus it self dot centroid. Let's centroids of I, and you're going to do the score of that. Okay, because you need to also do the summations and also remove the centroid from here. Okay, into 2 is nothing but a squared. Okay, because this is distance. If I go on here, you can see this is our centroid and this is our distance. So you need to removing this centroid from here. You need to calculate the distance from each of the data points. That's our this one d1 square. Okay, I mean WCSS. So sum and np sum of the number of clusters is group is equal to I is coming from here, minus self dot centroids of the I, and we're going to passing here the score. Okay, so now you can simply going to returning here our cluster group. Okay, let's say return here the cluster group. Let's say return the cluster group. Okay, now we're defining here another functions for actually elbow method, for actually printing this out, right? So you can define it here. So let's say def elbow method, because we already calculated the inertia, right? So we're going to pass in here our self and the x and the max of iters. Okay, max of k, sorry, how many k you can choose. Okay, this is the out of this topic because we're going to do in this kind for just calculating the album method, so that you can give it here number of clusters. Okay, that's why actually creating this out. So then I'm going to using here the for loop. Let's say for k in range of 1 comma max of k plus 1, and then I'm going to using here, okay, should max of k, right? And then you can use it here. Let's say k means, because you need to calculate in from the means square error. So k means we're going to use it here number of clusters. Let's say cluster equal to k, because if I see on here in the above method, we need to give it here number of clusters as well in the k-means algorithm. So that's why we're passing here the number of clusters. And then this cluster is coming on here. Let's say first I'm going to give it here one cluster, one single cluster, then 2 cluster, 3 cluster, 4 cluster, like that. So that's why I'm creating here and for loops. And then I'm going to passing here the max iterations. So max iteration, let's say you here self dot max iterations, that is coming on here, and that's our algorithm. That's called k-means. And then I'm going to fit it out. Let's say k-means dot fit underscore predict, and then you can pass in the x, and then you can pass assign it into a variable called inertia. Let's say inertias, so that you can see the value as well. So inertias is equal to empty list, and let's say inertias dot append. Okay, you can passing here k-means dot inertia. Okay, inertia, this one. Okay, dot append. Inertia is this nothing but coming from here, this inertia. That's why you calculate the inertia on here, I mean the WCS value. Now you can plotting this out. So you can using here plt dot figure. So let's say plt dot figure, but before it also importing this out. Let's say importing here matplotlib dot pyplot as plt. So we have in this one, so plt dot figure, we can pass in here, let's say fixed size, let's give it here 8,5, and then I'm going to using a plt dot plot, and you can pass in the one range. There's a 1 comma max of k plus 1, and then you can give in here inertias, and as well as you're going to give it here marker. Let's give it here marker as O marker, and also the line style. Line style is equal to, let's say, this one. Okay, and then you can using a plt dot title, let's say elbow method. Let's say elbow method, and then you have the plt dot x level is equal to number of cluster, and then you have the plt dot y level passing here, let's say inertia. Okay, it should be inertia. Okay, then you can keep it here on grid. Let's say plt dot grid and the plt dot show. As you're also going to returning here the inertia, so let's return it here, return inertias. Okay, so that's it. Okay, now we run it out and try to give it here some of the data and try to plotting this out. Okay, so I'm going to type it here more, because this is the base part of here, that how can you do this. Okay, let's try to write down some code for the testing purpose. I'm going to write up that. Well, so you already added the code here for generating some synthetic data. So you're going to using the Scikit-Learn. Let's say from Scikit-Learn dataset, you're importing the make blobs, and actually creating here some centroid, because into passing here inside the centroid, so that you can it will creating some blobs based on the centroid. So give it here 4 centroid. You can see 1, 2, 3, and 4. And as well as you're going to give it here some standard clusters. So you give it here 4 cluster on here, and you give it here number of sample. Let's say number of sample is nothing but 200, sorry, and cluster standard is nothing but the cluster standard that we created here. And you also passing the centers. That's our centroid. Then you passing the number of features as well as the random state, and store it inside the x and y, dependent and independent features. Let's see our data first, and you can see that how our data look like. So you have the 4 cluster that you can see in a without class. Okay. So, but in your real-time data, you cannot figure out that how many data point you have or how many cluster you have if you have the real-time data. So that's why k-means clustering is coming into the picture, right? So we actually calling this k-means because you're already creating this k-means, and you're already using this one and passing a number of clusters equal to tens. So why tens actually? Because you don't know that for the assumptions, you don't know that how many clusters we have. So we give it here 10 clusters. And iteration, let's give it here the 500 iterations. You can give it here 100, 200, 300. Okay. So then you're going to using here this fit predict and try to do the scatter plot of the cluster because we have the 10 cluster, right? So we're simply going to pending here 4 cluster here and also the centroid and how many centroid you have. So I'm going to give it here, let's say run it down. And you can see here, it is creating here some kind of centroid, but you can see here it have the 4 centroid because we actually give it to here, initialize to here, but not in there. Okay. So that's why you can see here some kind of centroid is coming here and there and again. But how can you calculate that how many clusters we have? Okay. So you can using here this elbow method, and you can see here the value is not even coming in the 5. So you can give it here 5 clusters. Let's try to give it to here. It's a 5 clusters. And let's start checking for the centroid. And you can see that centroid is nothing but 1, 2, 3, and 4. Okay. But one cluster is missing. You can see on here. And let's start running this elbow method again. And you can see here now it's starting but in the 4. So you can give it here the 4. And now you can see here, this is nothing but cluster in the 4 groups. You can see on here. Okay? This is how our elbow method actually work and how can we choose the number of cluster on here. Okay, you can see here all of the data, how it will decreases, okay, how it actually increases. So this is how you can getting here how many cluster you have, how can you choose them. Okay. So that's it for about the k-means clustering algorithm. Okay, in the next couple of tutorial, I'm going to creating here some kind of real-time projects because you need to also start our multivariate series as well. So next project we're going to do in using the customer segmentation, clustering segmentation problems, because this is one unsupervised learning problems as well as the k-means clustering problems. So that's it for today now. So thank you and bye-bye.